It is true that we have ideas for some topics, but not all. Although we assume that we know some concepts, in fact, the equivalent of that concept is only the experience that environmental factors provide to us within our perception, and if it is for me, time is at the forefront of these concepts. Even if scientists, philosophers and thinkers from the earliest times until today to put the concept of time in a complete mold and define it, they could not define the time with a definite judgment that this vegetable is tomato. What is time? How was it start? According to which parameters does it progress? What are the determining factor or elements of time? Can it be stopped, forward or reversed? Does it differ from person to person or from moment to moment, from situation to situation? We must deal with such questions in order to get to know the concept of time. Although the concept seems familiar, it actually continues to maintain its mystery simultaneously since our existence. Many clocks and calendars have been organized so far to measure time. For example, star and sun clock, atomic clock and GMT time we are using now. Every clock system had deviations and delays. Systems based on the movements of the solar system, of which we are part, were used to compensate for errors based on that system. Time is flowing. But is time only for people? Are other objects or living things unaffected by time? For example, a bee is not dying, a cabinet is not getting old. Of course, the bee will die and the wardrobe will also wear out. So, if time affects everything, apart from being a concept, it should have a presence outside of ours, time. Or should it not? Let's think about it. Physics generally has a field of study that is far from easy to understand. But Newton's physical work is exactly the same in our lives, and what Newton said about time is undoubtedly a reference for us. When examining a case, it is not correct to treat it with self-reference. For example, the explanation of 1 second as time in a second will make us count in our place while examining the concept of time. Newton described his most important work in Principia as absolute, real, mathematical time, whatever flows evenly, by nature, regardless of anything else. In physics, besides the spatial 3D dimension, the other dimension is defined as time. Newton's definition, he was separating time and absolute time from everyday language and saying that time cannot be subjected to an external influence and cannot be altered regardless. For everyday life, this definition is correct. None of us can influence time, none of us can return yesterday or see 13.00 tomorrow at 11 o'clock today. However, science does not always stand side by side with practice. Namely, imagine that you are looking at a watchtower and the clock hit exactly 12.00. When you hit 12 o'clock, you actually had a delay and you could only notice 12.00 when the image reflection in your mind was over, when the rays reflected from the watchtower, and then the image analysis in your mind was over. Yes, this is a very, very short delay even not to try, but let's think, while it can cause such investigations in our perception of light, it will examine the movements at the speed of light. If we can experience it, can tidal or pause be created over time? Physicists, who thought that the progression of physics had reached the peak in the late 19th century, realized exactly this question at that time. Or was it a theory that we know about relativity with the strength to turn it upside down? Of course, Newton was not the last scientist to talk about time. While processing the rules accepted by everyone, Einstein came up with brand new ideas and articles. In 1905, in his articles published in the journal Annalen der Physik, he said in his own words, "Time exists only with motion, with motion, with motion." In that case, object, motion, and time have no priority over the other. Galileo's relativity principle shows that the movement that does not change over time is relative. He proposed that there could not be an absolute and fully defined state of motion. According to the idea Galileo put forward, anyone on a ship that is said to have moved by an external observer can say that the ship is stationary. To explain, time, space and motion are not independent from each other, they are all related relative events. Object time, space motion, time motion are indirect and directly dependent on each other. The special relativity theory, which we encounter with many interesting results that cannot be perceived intuitively, but experimentally proven, makes Newton's concept of absolute space-time meaningless. The formula E equals mc2 includes energy, light velocity and mass. Special relativity gives the same results as the Newtonian mechanics at low speeds, as all speeds are less than the speed of light. If we talk more about this part, I will leave it here because we will enter a different subject. Einstein simply described it as follows: let's consider two observers, one as X, one as Y. The observer looks directly in front of the clock tower, so the observer Y moves in the opposite direction of the tower with the speed of light while hitting the clock exactly 12 o'clock. Observer X can see 12:01 o'clock, but observer Y constantly measures the clock at 12 o'clock because it has stopped some time. The time-stopping event is of course valid on a macro basis. When examined at the nano level, it will be noticed that the time does not stop but only slows down. Let us think this as follows: while an airplane is in motion, the vehicle traffic below will be observed as stopping, which is one of the situations that we perceive as slow or stopping when we intuitively observe other components while moving fast. Probably most of us have experienced such observable experiences. On the one hand, Newton's definition of time, where time is examined as the fourth dimension, except for the three dimensions known to be touched, altered, and space-time separately, on the other hand, is the definition of time in the system, where time, space and motion are considered as one. Time is such a concept that at the beginning it created differences of opinion. On the other hand, the relativity law is protected by certain mathematical and physical bases. It is the cost after that, which depends on the advancement of science and technology. Maybe we can't see, but one day, the rockets that can reach the speed of light and the scientists who will be researching there can be provided in a healthy way and they can convey the truth to us. However, there is no guarantee that new theories will not be produced until technology reaches that level.